Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at the auto keyword in C++11. So in C++98 we could type, of course, things like this, just creating a variable. And if we want, we could make that, for example, static. But we could also declare it auto in C++98, and auto is the default storage class specifier for your variables. So you normally don't need to type it out explicitly. Now in C++11, the meaning of auto has been extended, and we can actually miss out the type declaration altogether. If we're initializing a variable, we can make the type of it auto, and that will actually look at what you're initializing that variable with, and in effect declare the type for you. So we've still got an int here, it's just that C++ has figured that out for itself by looking at the fact that I've initialized this value with an int. This is particularly useful when you've got to declare really long sort of type declarations in situations where C++ is somehow able to figure it out. For example, if you're iterating through a vector with an iterator, which we'll see later on, auto can make that a lot simpler. So you can use auto pretty much anywhere you'd expect. It's very, very handy. Let's try a string here. So that's also going to work. Let's output text. We're going to get an unused variable warning on value probably. There we go. So we've got hello. So it's figured out for me that I wanted a string. Well, in this case, it's actually given me a primitive string. So if you literally wanted a C++ string, you'd have to do something different. But in general, auto is very useful. So we can also use auto for the return types of functions. This is where it gets a little bit more complicated. Let's say we have a function up here and we say auto test and we say return 7. Now this isn't going to work in itself, so we'll try to call test here and we'll build that and run it. So we get errors here because auto, well, it simply can't be used in this way. It needs more information to figure out the return type. Now C++11 introduces trailing return types, so after the function declaration we can type an arrow and we can type int for the return type here. So this now works. If we build this and run it, we get 7 being returned there. Let's maybe make it 100 since I've already got a 7 in the program. And you might kind of think, well, what use is this? And in this form, not really much use. It would be simpler just to type int here as you normally do. But it can be useful if you've got template functions. So let's say this is a template function. Let's give it class T. Whoops, I meant to say template class T. This is a template function as we've seen previously. And we could return something of the type T. Let's maybe do something like, I'll include this in the parameter list. Let's say T value, and then let's say return value. So it doesn't actually do anything other than return whatever we pass it. And let's pass it hello there. We'll pass it a string here. So this isn't going to work because I've got the wrong return type here. But what we can do is we can use decal type, which we've seen before, to inquire about the type of T here. So let's type decal type, declare type, and we're going to pass in value. So remember, you have to pass actual variables to decal type. Now if we run this, we actually get what we wanted. There's some warnings there, just unused variable warnings, but there were no compilation errors, and it actually works. You can even do stuff like if you've got two values here, class T, class S, and we're passing in another S. Let's call it value 2. We'll call this value 1, and we'll return value 1 plus value 2. So now you want the return type to be value 1 plus value 2. So we can use expressions in decal type to determine what the return value could be. We've got some error there. Let's just take a look. So yes, I've got to pass another parameter there, of course. Let's pass in, well, we're going to have to pass in two things that we can add together. Let's try 5 and 6, which clearly we can add together, a couple of ints there. So we run this, and it runs as expected. We can even call functions in here. So let's say we've got a, let's create maybe another function. Let's say auto test 2, and we're going to declare a function here called, let's say int get, and let's make get return a integer 999. Now we can make test return whatever get returns. So obviously your function is going to be more complicated than this in reality, but I'm just trying to sort of distill this down to its essence here. So that's not going to work in this form. We're going to get an error if we build this. But what we can do is have a trailing return type here, and we can use decal type here, and we can put get in it. So if I run this now, if I got this right, let's run it, then we get, it will actually work. So it's compiled. Let's actually call it and just see it. So cout test2 endler, and we'll run this. And it's, well, we've got 1. Yeah, I've output the wrong thing there. Let's actually call test2 and run it. So now we've got 999, so it actually works. So we can actually use a function in there. So we can type expressions in there, quite complicated expressions even. But the main things to learn here is firstly just that if you're initializing a variable, you don't need to put the type of it anymore unless you want to specify a particular type, like you want to say that this has got to be a C++ string class, rather than whatever it currently is, which seems to be, we're just getting the warnings there, but it seemed to be a char array. So you can just put auto instead, which is quite a time saver sometimes. And if you have a template function like this, you can still use auto if you want to. You might argue that it's confusing, but sometimes it could be useful. But the thing is, for the return type of a function, you've got to have a trailing type. So if you've got a template class, you're going to have to use decal type with a trailing type like this, so that auto can figure out what it should actually return. But that's something that could potentially be useful. So worth having a go at this. Just if you're a fan of C++, as I hope you are, then you're going to immediately want to try declaring some variables with auto. And it's worth just having a go at this as well. Try declaring a template class and use decal type with auto to determine the return type. So we're going to go on to see some, I'm going to use auto a lot from now on, so we're going to see more examples of it later, but it's worth practicing that. So until next time, happy coding.